Welcome to Future Epoch, where we learn more about our world. On the 30th of November 2022, a research company called OpenAI posted a quiet announcement on its website. There was no press conference, no launch event, no keynote. Just a link and a simple invitation to try a new chatbot called ChatGPT. Within 5 days, 1 million people had used it. Within 2 months, 100 million. It became the fastest-growing consumer technology product in recorded history, outpacing Instagram, TikTok, and every platform that came before it. But the real question was never how fast it spread. The real question is what it actually is, and how something built entirely from text predictions can appear to reason, explain, and even surprise the researchers who created it. ChatGPT is a large language model, or LLM. At its core, it is a system trained to predict the next word in a sequence of text. That description sounds almost trivially simple, and yet it conceals a level of complexity that researchers are still working to fully understand. The model is not a search engine. It does not retrieve information the way a librarian retrieves a book. Instead, it generates responses token by token, drawing on patterns encoded during a training process that consumed an enormous proportion of the text ever written on the internet, in books, and in academic journals. By learning the statistical relationships between billions of words and phrases, it develops something that behaves, from the outside, like knowledge, understanding, and reasoning. Whether it genuinely understands anything at all is one of the most contested questions in modern artificial intelligence research. The intellectual foundations of ChatGPT stretch back decades to early theories of neural computation and the first attempts to teach machines to recognize patterns in language. But the direct technical lineage begins in 2017, when a team of researchers at Google published a paper with a deceptively modest title, "Attention is All You Need." That paper introduced the transformer architecture, a new way of processing sequences of text that allowed a model to weigh the relevance of every word in relation to every other word simultaneously. Previous approaches had processed language one word at a time, which made it difficult to maintain context across long passages. The transformer solved this through a mechanism its authors called self-attention, which gives every part of a sentence access to the full surrounding context in a single computational step. It was a fundamental shift, and the entire modern AI language industry is built on it. OpenAI, a research organization founded in 2015 with a stated mission of ensuring that artificial general intelligence benefits all of humanity, moved quickly to apply the transformer architecture at scale. In 2018, they released GPT-1, the first generative pre-trained transformer, followed by GPT-2 in 2019. That second model was initially withheld from the public because OpenAI believed it was too capable to release without caution. In hindsight, it was an early sign of how quickly the field was moving. GPT-3 followed in 2020, trained on 175 billion parameters, the numerical values adjusted during training that encode the model's accumulated understanding of language. GPT-3 could write coherent essays, answer questions, summarize long documents, and produce functional code. But it was still a raw completion engine. It would predict whatever text seemed most likely to come next without any particular concern for whether that text was helpful, accurate, or safe. The breakthrough that made ChatGPT possible was a training technique called reinforcement learning from human feedback, or RLHF. Human trainers rated model responses for quality, usefulness, and safety, and those ratings were used to teach the model to prefer helpful and honest answers over purely predictive completeness. This fine-tuning process, applied to the base GPT-3.5 model, produced the conversational assistant the world met in November 2022. The central tension inside every large language model is the gap between what the system appears to be doing and what it is technically doing. From the outside, ChatGPT appears to reason. It appears to understand questions, weigh alternatives, and arrive at structured conclusions. Ask it to explain a complex concept, and it gives a layered, graduated answer. Ask it to debug code, and it frequently identifies the error. Ask it a trick question, and it often catches the trick. This behavior is so consistent and so convincing that even researchers who built these systems have expressed genuine uncertainty about whether something beyond sophisticated pattern matching is occurring. But the technical description remains. The model is predicting the most statistically probable next token, one step at a time, based on everything that came before it in the conversation. It has no persistent memory between sessions, no internal model of the world it is discussing, and no direct perception of reality. It cannot independently verify whether its own statements are true. It can only assess whether a given continuation is consistent with the patterns encoded during training. This gives rise to the model's most notorious failure mode, which researchers call hallucination. When the model lacks sufficient grounding in its training data, it fills the gap with plausible-sounding but entirely fabricated information. Names, dates, citations, and statistics can all be invented with the same calm confidence as accurate information because the system has no internal signal that fires when it crosses from recollection into invention. For the model, that line does not exist. GPT-4, released in March 2023, significantly reduced the rate of hallucination and improved performance across a broad range of reasoning tasks. Microsoft, which had invested $1 billion in OpenAI in 2019 and committed a further $10 billion in early 2023, rapidly integrated GPT-4 into its search engine, its Office productivity suite, and its developer tools. The competitive pressure this created triggered what many observers described as an AI arms race, with Google, Meta, Anthropic, and a growing number of other organizations accelerating their own large language model programs in direct response. The effects of ChatGPT's arrival were immediate and wide-ranging. Universities revised academic integrity policies within months of the launch. Law firms and financial institutions began exploring whether the technology could accelerate document review, contract drafting, and regulatory research. Software developers adopted AI coding assistants at scale. Radiologists, journalists, scientists, and educators all found themselves attempting to calibrate how much trust to place in a system that was frequently right and occasionally completely wrong, with nothing obvious to distinguish one state from the other. The question of employment effects became politically charged. Some economists argued that large language models would primarily augment human work rather than replace it, shifting the composition of tasks without eliminating jobs in significant numbers. Others pointed to productivity gains so substantial that a meaningful reduction in certain categories of knowledge work appeared structurally inevitable. The honest position, as of the time of writing, is that the long-term economic impact remains genuinely uncertain, and the evidence does not yet support confident predictions in either direction. What is already clear is that ChatGPT accelerated a broader public conversation about the nature of intelligence, the reliability of information, and the appropriate relationship between human judgment and machine-generated output. It moved artificial intelligence from a technical specialty discussed mainly in research circles into a topic that appeared at dinner tables, in school classrooms, and in government policy hearings around the world. The most important thing to understand about ChatGPT is not what it can do, but how it does it. It is a statistical model of language, trained at an extraordinary scale, fine-tuned through human feedback to be helpful and appropriate, and capable of producing outputs that can be genuinely useful or subtly wrong, sometimes within the same paragraph. The transformer architecture that underpins it was designed to capture relationships between words across entire documents in a single computational pass. Reinforcement learning from human feedback gave the model a preference for responses that human reviewers found valuable and safe. And scale, measured in parameters, training data volume, and raw compute, transformed those mechanisms from an interesting research direction into something that felt, to hundreds of millions of users, qualitatively different from anything that had come before. Understanding this does not diminish what these systems achieve. It clarifies what questions to ask of them and what kind of skepticism to apply when the answers arrive. A model that predicts language with high accuracy can still be wrong in ways that look exactly like being right. We are at an early stage of understanding what large language models actually are. The transformer architecture that makes them possible is less than a decade old. ChatGPT itself has existed for fewer than 3 years. The systems in development today are more capable by orders of magnitude than anything that existed when the foundational research was first published, and there is no clear sign that the trajectory is leveling off. The question that will define the coming decade is not whether these systems are useful, because they clearly are. The question is whether the gap between apparent intelligence and genuine understanding matters, and if so, in what circumstances and how much. A tool that is almost always right, but cannot tell you when it is wrong, demands a different kind of critical engagement than any technology most of us have encountered before. The most consequential technologies are rarely the ones that arrive with the most fanfare. Sometimes, they are the ones that become so ordinary so quickly that we stop asking how they work. ChatGPT arrived without ceremony in November 2022, and within months it had changed the terms of that conversation entirely. Whether that change ultimately makes us more capable of understanding the world, or simply more comfortable with the illusion that we do, remains the question worth holding on to. Thank you for watching. If you've enjoyed this content and want to see more, please consider liking the video and subscribing to the channel.